followers of my YouTube channel. Welcome to my tutorials. For today's tutorial, we will start HEC HMS modeling for urban hydrology. For urban planning or urban flooding. Therefore, we have already finished modeling on HEC HMS, and your next task should be working on HEC HMS. Therefore, this is a folder what we have doing on the HEC HMS. Therefore, you should have to have a copy of this HEC HMS, because if you have made mistake when we are doing on HEC HMS, we can get the original data from this one. Therefore, you should copy, select all data, and should have to create a new folder and paste in such a way. And I have prepared a copy of my HEC HMS model under this HEC HMS. Okay, so I will work on this folder. So to start with, let us open a new HEC HMS model, and open your HEC HMS in that newly opened HEC HMS. Okay, therefore this one is the window interface of HEC HMS. This one is a file edit, and different components are there. Alright, here is the views here. After you are uploading your files, you can view different components like map layers, and we have components, time series data here, control specification manager, methodological model manager, busy model managers, and here is also the GIS components, the coordinate system, the pre-processing things, and the likes, and also different parameters are there. So after you have opened this HEC HMS, go to file, and since we have open a new file here, say open, and go to this browse. Okay, and the copy of my HEC HMS project is located under D. Alright, so it says HEC HMS, this one. Under this gilgalabai.hms is input file. Okay, so select it. Alright, therefore if you have expanding the spacing models, gilgalabai. Okay, this one is Bayesian models. Alright, so for instance, this one is the shape. You can add those components under view. Okay, there is map layers. We can add those components. Okay, the map layer and the river, it's a Bayesian as well as the river, from your working folders. For instance, you can go to this add, and you can add your rivers and Bayesians. Okay, such a way. And also you can draw the properties here. We can change the color ramps of your Bayesians. For instance, if I would like to change the color ramp in such a way, you can simply change the colors. And also we can change the river color. It may be blue. We can say dark blue. Okay, if you say, we have changed the color ramps in such a way. So we have doing those things such a way. And there are methodological models here, the gilgalabai. Okay, precipitation gauges. Those precipitation gauges are the gauges that we are conducted on the Tyson polygon, alright, or the Tyson polygon. And also there is a control specification here. This control specification governs the time, the starting time and ending date of your data, okay, your data. And there are time series data here, the precipitation gauges. Those are the stations what we are used for the Tyson polygon on the HEC HMS. Data kunna Dangilla, Njibara, Gundil, Kasa, Kwari, Sakala, and Wetatabai. Those are the meteorological stations, okay, what we are used in the Tyson polygon. Therefore, after you are visualizing those things, you should have to first specify the control specifications. Okay, so the first thing here is specifying the control specification. Go to this control specifications, by this one, double click on this, and here is under the component part, you have description. Just you can write as by HEC HMS project, and the starting date of simulation here is depending on your data. For instance, the input data for this tutorial purpose, for instance, meteorological data, the rainfall data for a date here starts from 1994, right? 1994. Therefore, you can give the starting date is 1 January 1994, and the ending date is 31 December, okay, 31 December 2008. So for all stations you should have to give this value, this starting dates for control specification. Therefore, under this you should have to give that 01 January 1994 is the starting date, and start time is let us give a 00. Ending date is 31 December 2008, as we have seen before. And the time interval here is basically in our country most of the data are collected in daily time step. You see, daily recorded data. So you should have to select 1 day time interval, and after you have given this, save your work. Okay, save your work. So the first task is now accomplished, and after you have specified the control specifications, next you should go to this meteorological model. Alright, this meteorological model, expand this one, and under Google Abai we have those watersheds. Alright, watersheds, and those are the gauge weights and the likes. Sorry, one thing here under control specifications, we have inserted on the components, and after we have simulating our model, we will get we will run our model under this, and we can visualize the results under these components. Okay, so we will see those things one by one. And under this meteorological model, expand this one, and we have a lot of these gauge weights for each watershed. For instance, this W260, if you see here, W260 means this one, okay, and W270 means and I hope we can visualize by zooming your works in such a way. Goodness. Okay, therefore to do that, expand this one this gauge weight, the gauge weight. Under this, for each sub watersheds, okay, for each sub watersheds, um, you should have to give the time weight. Okay, mostly this depths weight equals the time weight. Okay, under the component, you should have to give the depth weight equals the time component. So copy this one and paste here for all. Okay, copy and paste your values here, actually, in such a way. Let me, this one is similar, which means that for this W 260, the gauge weight, if you see the gauge weight, only gauge وتتعبي or only وتتعبي contributes. Okay, only وتتعبي contributes for this watershed. And if you see the second one for W270, also Watatabay is contributing sub-watershed, stations, and also you should give that alright, good. No way, you can write. Okay, you can simply copy and paste in such a way. You can use the keyboard. Okay, the keyboard, and go to this W 280. Here is also what a tab by, and come on here, paste your time weight, and also this W at a tab by, it's also at a tab by. Okay, such a way. And this one is Dangla and what a tab by. You see, for this W300, the contributing sub-watersheds are Dangla and what a tab by. Therefore, you can copy and go to this one and paste your data in such a way, and go to this W310. For this case, Dangla and Jivara and Wetatabai are the contributing stations for this watershed. Okay, that means this watershed obtains rainfall from Dangla and Jivara or Wetatabai. So it tells us that one. And copy this value similarly and go to this W 320. This one is only what a tab by contributors. Okay, in such a way we can put the time weight. Okay, we can give the time weight for all stations and watersheds. For this case, Zakala and Rotatabai contributors. Okay, copy, go to this one, paste your time weight, and for this one only Dangla. Okay, and for this Dangla and Injubara. Okay, so it is similar work. It's better to pause. So we have inserted time weight for all sub-watersheds in such a way. Okay, you can see time weights. Okay, time weights. for all the watersheds in such a way. After that, you should save your work. You should save uh, your work. By default, we may made some mistakes when we are copying and pasting some data. Okay, therefore you can open your original HEC HMS model in a new HEC HMS, and you can get the correct value for depth weight or time in weight from that. Okay, so if you are working the control specification and meteorological models in such a way, the third task here is go to this time series data. Okay, here is a precipitation gauge. This is a precipitation gauge of all stations. If you expand this date, we have those time intervals. I mean the control specifications for this one. So for this case, the first thing you should have to do is on time series gauge, you should give the description. This one you can give the description, and here is data sources manual entry, since we are giving from our data, and the unit here is incremental inch, so you should adjust this as incremental millimeter. The rainfall data is measured in millimeters. Okay, in millimeters, and the time interval is similarly daily data. This is the daily data, so we can give the time series in such a way. So I save your work and go to this time window. Under this time window, for instance, for the added rainfall, the added rainfall starts from that of 94, but you should give the date. This starting date should be before one day of the starting date. Okay, therefore our day starts, the daily data starts from 01 January that of 1994, but you should give one day before that one. It governs under these tables. Okay, since this the initial table is not considered, that is why. Therefore, for this case, I should give the 31 the December 1993. That means before one day of the starting year of our data. And here the ending date is similarly, it is 31 December 31 December, December 2008. This one is the ending date, and if you see the table here, automatically the tables are extracted. You see the starting date is 01 January 1994. This day is now not considered, but we are given the starting date before one day before our data. Okay, starting date of our data. And one thing you should have to do here is copy and paste your data here. And if you see here, the ending date is 31 December 2008, and the starting date is this one, 01 January 1994. Therefore, to do that, let me open my data here, this data. Alright, and here is the meteorological data. This one, Control plus A. Okay, copy and go to this one, paste your data, so we can check that here is your precipitation data, and you can visualize your graphs. Can visualize your graph in such a way. I hope it is very simple. Therefore, we are under component, and after we are running our model, you can see the compute and results. So this is how can we insert precipitation gauge for added station. Similarly, we can do for Ascuna. You can give the time incremental manual entry, and it should be incremental millimeters, and the time interval is daily data, and the time window here is similarly you can give this 31 December, yeah, 31 December 1993 here, 1993, and the ending date is 31 December 2008 here, and we can see the table here. The table is now automatically created, and the graph you can copy and paste your data here. Alright, Skuna and Control plus A here. Okay, copy, Control plus C, and go to your HEC HMS and paste your data here. In such a way you can visualize your graphs. You can see the starting year and ending year of your data. Therefore, after you have inserting your data, you can save your work. Okay, therefore in similar way we can insert our precipitation gauges for all meteorological stations, and it is one of the ways on how to insert our precipitation gauges in different stations. So I think it is enough for today's tutorial, and if you have any questions you can put under the comment section. Don't forget to share and subscribe my channels. Have a nice time. Have a nice time for today. Thank you.